Thanks for reviewing with me today. If you would like to work ahead, that is totally fine, but if you want some help going through this worksheet, I'm here for you. So we're going to start with some basic SOHCAHTOA. And since it says theta, we're going to be working from this angle, and that would make this the hypotenuse, this the opposite, and this the adjacent. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And then these are all lined up really nicely, but make sure that you know that cosecant is the reciprocal of sine. So this one will be 5/3. And secant of theta would be 5/4, the reciprocal of cosine. And cotangent is the reciprocal of tangent, 4/3. These are for you to type in on your calculator. You'll need to be in degree mode since all of these are in degrees. I want you to type in sine of 72 and make sure you're getting this for an answer. And then to type in cosecant, you need to type in 1 divided by sine of 72. Again, your calculator would need to be in degree mode for that. I'm just going to go to 3 decimal places. I'm going to let you finish those other ones together. As long as the sine ones came out the same as mine, you should get the cosine and tangent ones. For filling in our special right triangles, this one was meant to be the 45, 45, 90. With sides 1, 1, square root of 2. And this one is the 30, 60, 90. With sides 1, 2, square root of 3. In this position. And those are the triangles that we'll use to do problem number 4. So just going off of whatever angle is mentioned, on this one it's a 45. You could pick either 45. Sine of 45 would be 1 over the square root of 2. That's the exact value. If you type that in, you'll get 0.7 or something. I do want you to rationalize the denominator, so square root of 2 over 2. Cosine of 60 would be adjacent over hypotenuse. That one's 1/2. Tangent of 30, TOA, 1 over the square root of 3. And we would want you to rationalize that one too. Cosecant of 30, so that's upside down sine. So I'm going to do h over o from the 30-degree angle. H over o will be 2 over 1, so just 2. Secant is cosine's reciprocal, so I'm going to do hypotenuse over adjacent from the 45. Hypotenuse over adjacent would be square root of 2 over 1. And cotangent is going to be adjacent over opposite from the 60. Adjacent over opposite. So square root of 3 over 3. Now we're talking about graphing those angles. Remember that angles in standard position always start with their initial side going to the right on the x-axis. And we're going to start rotating up. And 160 is going to come just shy of 180. So that would be a nice picture. Negative 400 just means we're rotating the other way. Still starting with our initial side here. But since it's negative, we'll start by rotating down. It's going to go to 360 plus another 40. So our terminal side would be in quadrant 4. When we go to radians, just remember that the top half is pi radians, so we're always going to think of splitting our pi. Pi divided by 2, it's kind of already split into 2 by that axis. Initial side, and we're going to count 5 of those pi over 2's. 1, 2, 3, 4, 5. And since we landed right here, that's where our terminal side goes. And the last one I'm going to want to split into pi over 3. So we're going to take each pi and divide into 3 parts. On this one, we kind of have to ignore that y-axis. I'm going to split the bottom as well because it looks like we're going to be rotating negative. So starting here, we're going to count 2 of those pi over 3's. 1, 2. And that's graphing angles in standard position. And now those same angles, we're going to figure out the coterminal angles. The coterminal angles are just any other angle that starts on the same initial side and ends on the same terminal side. So for this first one, I'm thinking we could go negative. How big of an angle's in there? That's a 20 in there. So 180 plus 20. And then for the positive one, we would just loop around once. So 360 plus another 160. Did I do that right? Yeah, we're good. Negative 400. So remember we went around 360 plus another, would have been 40 extra. So that would be a negative 40 degree angle. And I guess if we went the clockwise way, the positive way, if we stopped 40 degrees shy of 360, that would be 320. Now you can always go this route where we can add and subtract 360 from those. I just like to use my thinking brain and look at the picture too. And on these especially, like instead of adding and subtracting 360, we would have to add and subtract 2 pi, which in the case of a denominator of 2, we would be thinking of 4 pi over 2. But I prefer just to look at the picture. So if I need to start here and end here, that would be 1 pi over 2 for my positive one. And if I go the negative way, that's 1, 2, 3. So negative 3 pi over 2. And then for negative 2 pi over 3, I could go the positive way. 1, 2, 3, 4. 4 pi over 3. Or I could loop all the way around and hit it on the way back. So what would that be? 1, 2, 3, 4, 5, 6, 7, 8. And I was going the negative way, so negative 8 pi over 3. For converting, remember we just have to choose the conversion factor of either pi over 180 or 180 over pi. 500, I want the degrees to go away, so I'm going to put the 180 on the bottom to cancel the degrees. And we would just multiply straight across, so that would be 500 pi over 180. And we'd reduce that down, I'm thinking 25 pi over 9. So then converting to degrees, we're just going to use the opposite one. So 5 pi over 8, multiplying by 180 over pi. That way we'll get degrees in our answer. And here the pi's will cancel out. So multiply straight across. 5 times 180 is 900. 8 times 1 is 8. 900 divided by 8. 112.5 degrees. And then for arc length and sector area, those formulas are S equals R theta and A equals 1/2 r squared theta. And the big thing to remember is that those thetas have to be in radians in order for this formula to work. So I'm going to grab my angle and just switch it over to radians right away. So I could do the same as I did in part A up here and convert that using radians. I kind of like to think of this as a 260-degree angles. And what do you have to split 180 into to make 60? You have to split 180 into 3 pieces, true? So this is actually a 2 pi over 3 angle. Again, if that didn't make sense, go ahead and just use that conversion factor and just multiply by pi over 180. And here we go, we're going to find arc length. So we'll take the radius times the angle measure in radians, and you'll just type that in. We don't want it in terms of pi since we're actually trying to figure out a length anyway. I'm getting about 10.5. And that would just be units. And then the area, 1/2 r squared times theta. And just type it in. Hopefully you're checking me. I don't have anybody to compare answers with right now, so 26-ish. That would be in square units. All right. Now it's time to find some reference angles. Best way to find our reference angle is to just graph the original angle. So I've got a 410, so that'd be 360 plus another 50, right? And as long as you've drawn it, you've probably figured out that the reference angle is 50 degrees. Again, a reference angle just takes that terminal side and connects it back to the x-axis to form an acute angle. So all reference angles are both positive and acute. And our first answer is 50 degrees. Negative 135. It's past the 90, not to the 180. How far away from 180 would that be? Is that a 45 degree? So that is our reference angle because it connects the terminal side to the x-axis. I'm looking for the positive acute angle. So positive acute angle for reference angles. We're doing splitting pi into 3, so we'll split the top half into 3, have to ignore the y-axis. Bottom half into 3, ignoring that. And we're going to count 5 of them. 1, 2, 3, 4, 5 brings us to this one, leaving us just one shy of the x-axis. So our reference angle would be this little guy in there. So just 1 pi over 3. Here we've got a pi split into 4 pieces, so I can actually use that y-axis. And I'm going to count negative 5 of those. 1, 2, 3, 4, 5. Brings me to quadrant 2. And if I want to connect that back to the x-axis, that would just be one little pi over 4 section. So pi over 4 is the reference angle. And then the unit circle, we learned this on Friday. For points on a unit circle, sine is always going to be the y value, cosine is the x, and tangent is the y over x. And if you ever forget that, here's maybe a way to remember. So if we put a triangle in the first quadrant, here's the x, here's the y, and if it's a unit circle, our radius would be 1. We're thinking of this as being stuck in a circle there. So the radius is 1. So then if you're working from this angle, opposite is y, adjacent is x, and opposite over adjacent would be y over x. So hopefully that helps. It makes sense, or just memorize it. And then these are the big problems we had to learn how to do on Friday. So let's review that. Step 1 is we're just going to graph the angle. So everything we've been learning is kind of leading up to this. So we learned how to graph an angle in standard position. We learned how to find the reference angle, in this case a 45-degree angle. And then what we're going to do is we're going to drop that to the x-axis always and make ourselves a little triangle. And it's a 45, 45, 90, 1, 1, square root of 2. We also have to think if any of those would be negative. So in the second quadrant, an x value would be negative, but a y value goes up, so that would be positive. And the hypotenuse is always positive. The hypotenuse is always positive. And we're going to do cosine. Cosine is adjacent over hypotenuse. So we do get a negative value, and we'll write that with a rationalized denominator. This next one, we actually don't get to make a triangle. So we're going to start at 0. We're going to count to 180, but the reference angle would be like 0. So you can't really make a triangle, and that's where we pick our point, and we think of that as being on the unit circle with radius of 1. So if that guy has a radius of 1, this would be the point -1, 0. And then we go back to our little definition here where cosine is the x value at that angle. So cosine of 180 would be the x value, -1. Splitting into 4 pieces. And counting 7. 1, 2, 3, 4, 5, 6, 7. Leaving us with a pi over 4, a 45-degree reference angle. So we got ourselves another reference triangle of 1, 1, square root of 2. Just remember to think, are any of those negative? And in the fourth quadrant, x's are positive and y's are negative, and the hypotenuse is always positive. So then from that reference angle, we're going to do negative square root of 2 over 2. Okay, so if we're splitting pi into 2 pieces, the axis has already done that for us. So negative pi over 2 is the same thing as negative 90 degrees. Again, we can't really make an acute reference angle. We don't really make a triangle when this happens. What we do whenever we land on an axis is we think, what would that point be on a 1-unit circle? So we'd be going down 1, so that would be 0, -1 would be the point on the unit circle. And then tangent was y over x. So we'll do -1 over 0. Although you cannot divide by 0, so it turns out the tangent of -90 degrees is undefined. Tangent of negative pi over 2, undefined. I'm thinking we're going to get to see a little 30, 60, 90 action here. Splitting into 6 pieces. 1, 2, 3, 4, 5, 6, and counting 7 of them. 1, 2, 3, 4, 5, 6, 7. So just one little click past would put us 30 degrees past 180. Since that was pi divided into 6, 180 divided by 6 is 30 degrees each. Once we get our reference angle, we just connect back to the x. 1, 2, square root of 3. And down in quadrant 3, we have a negative x value and a negative y value. The hypotenuse is always positive because it's considered like the radius of a circle. If we were to make that fit inside of a circle, that 2 would be its radius. So we always leave the hypotenuse positive. Tangent TOA, opposite over adjacent, negative 1 over negative square root of 3, which actually will come out positive. Tangent is like the only positive one down there. If you're comparing to sine and cosine, would both turn out negative. Tangent turns out positive, and we'll rationalize the denominator too. I hope these are getting easier. You might want to try one on your own. Landed on an axis, so I have to name the point. Make sure you get them in the right order. Sine is the y value, so my answer is 1 for part F. Okay, last one. When you land on an axis, you pick the point. Then you just have to remember cosine is going to be the x value. So 0 is cosine of 3 pi over 2. So did you notice that we didn't use a calculator on any of these, right? On some of them, we would get the right answer if we typed them in. On some of them, you don't get those exact answers. And so you should be prepared to draw the picture and give the answer. That's how you're going to get your credit for doing those. All right, thanks for reviewing with me.